Hello, Spulin sir here. I welcome you all for this video. I have been giving you uploading videos on many chapters. Real number I did, polynomials I did, and then we finished with linear equations recently. Only one more video I have to do. But all videos are done with the help of graphic tab, where you have only heard about my sound, right? But today I'm coming physically because I felt that it would be a different experience, right? So I'm bringing today to you a new chapter, that is trigonometry, right? And it is one of the most important chapter of your class 10 syllabus, right? And let me try to tell you that trigonometry will always be very important for your future studies, whether you are going to take maths or not. It's different. But if you are going to appear some tests, right, competitive exams, then it's very sure that you need to know trigonometry, right? So let's begin with the very important topic of class 10, right? Let's see we'll be able to enjoy or not. Okay, let's start. Okay, so first, as a normal procedure, I'll write a name and I'll explain you what exactly the name tells, because everything lies over there only. And then we'll try to grab continuously the grip on the chapter. Okay, let's see. Trigonometry, right? Trigonometry. So this particular word will divide into three parts, and then we'll see how these words gives us a very important meaning, right? We'll divide it like this. Tri. Each one of you know that. Tri means three, right? This is three. Okay. Gone. Gone. Gone means sides, right? It's sides. And metria is measure. Metria is measure. Now just decide yourself. Three sides measure. Where will you find it? Very natural. A triangle, right? So that means trigonometry is something which is related to triangle. But remember, it's related to a very special triangle, that is right angle triangle. So begin with, let's see what is there inside. Okay. So anyway, instead of drawing a figure, I'll show you a small visual aid, right? I'll not say that this is a model. This is just a visual aid which will help us, right, in the whole course of teaching and learning. You can see this. You can see this. This is a triangle. I named it as PQR. This is PQR. Q is the angle 90 degree. So this is a right triangle. Is it clear to you? Second thing, if this angle is 90 degree, then these two are going to make together a measurement equal to 90 degree. Great. Okay. Next point. These two angles of this right triangles are definitely acute. Acute angle means those angles which measures between 0 and 90 degree. 0 degree is not taken, 90 degree is not taken. It should be precisely between 0 and 90 degree. Is that clear to you? So whenever you take a right triangle, you'll always get a 90 degree angle like this, and then the other two angles are very definitely acute. Very definitely acute. Next point. There is one quantity which never changes in a right triangle. That's the hypotenuse, right? Never changes means I'm not talking about the measurement, right? If it is a different triangle, measurements might change. I'm talking about the name, because I'm going to redefine the other two sides by giving some other names, right? Always, no matter how you hold a triangle, right, in any case, the hypotenuse is identified just by looking simply opposite to the right angle. This is a right angle, stand here and then just opposite to it, stare. This is what? The hypotenuse. Great, right? So this is a good chance. If you even rotate it like this, you can easily identify where the hypotenuse lie. What it is? It's here, right? How did you identify? Standing here, just see opposite. Okay, so there's the identification of the hypotenuse of a right triangle. Once you know where 90 degree lies, fine. Now to start with trigonometry. In this particular triangle, we have to fix one of the acute angle. Choice totally lies on you, right? In order to start with, right? But whenever it will be a problem, they will specify that particular acute angle, right? Now here, for my convenience, right, or maybe to write it conveniently, I've chosen this particular angle. This particular angle, I named it as theta. Let me again try to tell you. In case of algebra, if any unknown quantity comes, we consider that as x or y or z, right? Any variable we give. The same thing we do here when it comes for the angle. We write theta. Some other symbols are there. Phi is there, psi is there. Forget about that. Our theta will be okay, fine. So this is the acute angle which I fixed now. I'm going to talk about the other two sides with reference to this angle. Got it? If I would have chosen this angle, then these two sides would have been given some other names, given some other specifications. So do not go for this angle present at this moment. Let's come back here. Right? Please concentrate. This is the very important part with which our trigonometry begins. This is theta. Already you identified this particular side as hypotenuse. There's no doubt about that. Stand here, just go opposite. Just go opposite. This is known as perpendicular. Right? This is known as perpendicular. Anyway, better and correct. Right? It's better and correct to say that it's opposite side. But for our memory aids or for our definitions of trigonometric ratios, we would call this as perpendicular. Got it? So far we have named two sides. One hypotenuse, another perpendicular. What was the criteria of defining perpendicular? The angle you have chosen, from that just see the opposite. Opposite. Got it? Then you are left now only with one of the side. This one. Red color one. That is known as the base. And better to say it to be adjacent side. Adjacent, neighboring. Whose neighboring side? This angles. So this angle has two neighboring sides. One is the hypotenuse, so other one is the base. So you got a clue, right? Whatever angle, acute angle you choose, the neighboring side is always the base and left one will be perpendicular. Got it? So we have got now three different measurements of the sides. Hypotenuse, perpendicular and the base for this particular angle. Had it been like this, what would have been the name of the sides? This will still remain hypotenuse, there is no doubt, right? If I choose this angle, this will become perpendicular, right? Because this is just opposite to it, and this is the adjacent, and this will become the base. Now I can easily compare. Earlier when I considered this angle, it was my base, the red one. Moment I consider this angle, green becomes the base. Got it? So you should now understand what is the importance of choosing this particular angles, right? And if you make a mistake, then Christ, everything will be wrong, right? So let's start with something which is in writing. Okay? So this triangle I'll draw. I'll explain everything with reference to that triangle only. Okay, let's start with. And I would definitely suggest you with this video, when it will be on, you will play it, you go on writing it, note it down, right? And if needed, pause it, write it, again play it. Okay. So what we did, we had a triangle, right? We had a triangle. This is P, this is Q, this is R. We call this as hypotenuse, right? You all know what is hypotenuse. Again, I should not repeat. This we denote by h, small h, for our convenience, right? And as I told you, I'll mark this angle as theta. Then this would be called as base. We'll be using a symbol B for that, right? Letter B, small letter B. Again, I told that this better we should say to be adjacent side, right? So I'm writing that also so that I will not miss any particular part. Adjacent side. Then the side opposite to it is known as, I'm not writing perpendicular completely. I have written part P-E-R-P. And the letter I use is small p. And this is rather, it is better to say it to be opposite side, right? Opposite side. So these are the things which we must know once we fix the acute angle. Now you observe, we got three measurements. P, perpendicular, that will have some value, right? Some measurements. B will have some measurements, and in H. That means these three sides of the triangle will definitely have some measurements. They are numbers, right? And now if they are numbers, we can find the ratios. So we'll try to find all possible ratios of these three quantities. And they are the trigonometric ratios. So you can now think it's not at all difficult. It's just about the ideas what we'll try to imbibe, right? Okay, so right at this moment I have a lot of space in the board, so I'll be writing this. Okay, I'll write something here below, right? If I'll miss, then I'll write that side. First of all, we are going to talk about the ratio P and H, right? Perpendicular, ratio perpendicular with the hypotenuse, right? So P by H, something value will be getting, right? So that will be known as sine, right? But remember, I made a mistake. Purposely I did it so that you can understand what mistakes I did. My mistake is that I did not specify which angle I have taken, because if you take 90 degree minus theta, your P would be different, and if you take theta, your P would be again different, right? So you be very, very specific to specify this theta. Otherwise, you will get everything wrong. Again, I am warning you. Fine. Then is cos theta, that is the ratio of base to the hypotenuse measurement, and then is tan theta, that is P by B, that is ratio of perpendicular with base. These three are the three things which you have to remember, right? We'll be giving you memory aid. There are many memory aids which are already on use, which I used in my study time, so I'll be sharing all that. But thing is that these are the three things which you have to remember. You cannot afford to forget this at any moment if you carry on trigonometry, right? These are the very basic fundamentals of the chapter. Fine. I'll be coming to the memory aid, but before that, let me talk about the others one, right? If I have a ratio of P and H, then definitely I'll be getting a ratio of H and P also, right? That is just, I'm talking about the reverse, which you call reciprocal, right? Okay, we are talking of the reciprocal. So what we'll get here, if we reverse that ratio, that is H by P, and we call it cosec theta. Then if we reverse sec, that is if I take the reciprocal of cos, then I'll be getting the ratio of hypotenuse to base, that's known as sec theta. Remember, every such measurements presently I am doing with reference to this angle theta. So if I'm talking about perpendicular, then I'm talking about this side, PQ. Right? If I'm talking about base, I'm talking about QR. Be very precise. and then we have cot of theta, that is b by p. B by p, ratio of base to the perpendicular, ratio of the adjacent side to the opposite side. Right, now whatever is useful for you or easy for you, you try to remember it, right? I might be calling it as p by b, or I might be calling it as adjacent side or opposite side. That depends on me what I say, but whatever you feel comfortable, do that, right? So that totally depends on you, because nobody is going to ask you in the exam if you write 3 by 4 thinking in mind that it is p and b. Nobody is going to trace that out, right? Idea is to get everything correct, that's all. Okay, so now we have got 6 ratios. We have got 6 ratios. Now I'm going to give you the memory aid, right? How we'll remember this, because as I told you, these are the basic, very fundamentals. Fine, I'll rub this. I'm taking a little more time in explaining this because this really needs time. You have to invest time, and you should do it so that in the same go you can cover it and you need not return it to this point again, right? So I'm going to write the memory aid, which are traditional memory aids. Actually, we have been using it. I have a memory aid, but which I cannot share it here. The problem is that I have to use some words which are foul words, right? So you can understand that is not actually good to share, right? Okay. Now, what I'll write is, some people, right? Some people have curly black hair turned permanently brown. Some people have curly black hair turned permanently black. Be very sure I'm not bothering about the wordings. I'm not at all bothering about the correction or the correctness of the spelling. I only bother about the first letter of each of the word, right? So you consider every 3 words as a group, and then you try to decode what does that give, right? So every 3 words a group. You will not reshuffle this word, that should be in the same order. Some, starting with S. So this S will remind us of sine, right? It will remind us of sine. Okay, we'll have to add theta. As I told you, without theta, sine doesn't have any meaning, right? Then this will remind you about P and H, right? P will come at the top, H will go down, P by H. Correct? Fine. Then next is Kali. C will remind you about cos. C will remind you about cos. That is B by H. B by H. Correct? And then last you got turn permanently black. Sorry, brown. Anyway, that doesn't make any sense. I need B only, right? So turn permanently brown. T will remind you of what? Exactly, you got it. That is tan. Tan of theta will be equal to P by B. That's it. That's it. So you have done, right, the 3 ratios which are very important for trigonometry. Remember memory aid? Fine. Okay, let's move on to the another memory aid, because this may not be very comfortable for you. So I give you the alternative. Remember, it's not my memory aid. I have got it. I use it in my student life. I'm just passing it on to you, right? My own I cannot share, as I told you earlier. The problem is that I have some foul words which I cannot share here, right? Foul means that's not like slangs, but these words are not constitutionally accepted at least as an educational purpose, right? Or maybe I can criticize some other countries which is not allowed. Okay, thank you. So now I'm going to give you another option. That is funny, and that's good. Once your memory aid becomes funny, then it's very easy to remember, right? You'll never forget it. You'll never forget it, guarantee, right? So, first of all, think about something called Pandit, right? Pandit. There is a Pandit named Badri Prasad, right? My apology to all Pandits. I don't have any intention to hurt anyone at all, right? Pandit Badri Prasad, right? There's a Pandit named Badri Prasad. Normally Pandits, they are using what? They are doing pujas, right? Hari Hari Bol. Okay, that's a great word which we use, right? Normally we hear it from the Pandits. So we have clapped these two strings together. Pandit Badri Prasad, Hari Hari Bol. Right? So here, the first will give you sign P by H. Just put a division sign. P by H. B by H cos. P by B. P by B 10. That's all. And then you have to remember the reverse one. Right? Sine. The reverse is cosec. Then cos, the reverse is sec. Reverse, I'm talking of the reciprocal, right? And because reverse is not the correct word. Mathematically, reverse is not the correct word. But for understanding, I'm telling you, I should have told this as reciprocal. And then last 10, reciprocal is got, right? So we have got the 6 ratios. Okay. So now before we proceed further with any problems or any other things, right, we'll be getting some relations with these only, and we'll have to know the complete name. These are not the complete name. Tan theta, sine, etc. are not the complete names. We should know the complete name with the spelling, because that will help us to generate the next phase of formula, right? Okay. So, first let us know the full names of these precise and important 6 ratios of trigonometry, right? SINE, sine. This is the full name of SIN. We use only 3 letters basically. For cosec, we use 5 letters. Otherwise, we have 3 letters for the remaining ratios. Then cos, right? Cosine is cos. Cosine is better known as cos. Think about nickname, right? Every actor has a nickname, and the name which is reflected is actually not the actual name, right? So similarly, we know these actors as this. The behind background names are this. You must know that also. Then we have tangent, better known as tan. Better known as tan. Cotangent, better known as cot. Secant, better known as sec. Cosecant, better known as cosec. Your task is to remember these things. Remember, I'm not going to tell you to remember this many formula. I'm only telling you, remember those 6 ratios, remember these names. Then I say I'll make your trigonometry much easier, and you needn't bother about remembering any other formula. I'm going to give you such a good idea, brilliant idea, that you'll never forget your formula in your whole life. I bet that. I challenge it. Okay. So it's all done. You please note it down, pausing the video for 2 minutes, and make sure that you understand this. Before I close this, right, I wrap this, I'd like to tell you one more thing. There is something which is very very important happening over there, right? I don't know whether you have observed or not. That observation is going to work for me as a memory aid, which will be helping you to remember many of the formulas, right? So let's see what is happening here. Look at this. This is sine. I'm underlining that. Can you find sine somewhere else? Forget about the right side. Do not go for right side. Yes, sine is here. What is the difference between them? In terms of wordings, right? I'm not talking about definition. What is the difference? Sine upper. And then below what it is? Sine. Then there is a prefix. Co. Prefix. Matlab something which you fixed before. Right? Prefix. Sine with prefix co becomes cosine. One important observation. Can you find the same observation with the other ratios? Is there any other ratio where you will find the same observation? Yeah, exactly. Yeah. So tangent is present here. Tangent we prefixed co to obtain cotangent. So there's a link, right? Secant, it is here. Simply we prefixed co to obtain the cosecant from secant, right? Remember this, because I'm going to take the reference of this particular observation in the next video probably, right? If today I cannot, I'll definitely take this reference in the next video, very definitely. That time I'll not write these names again, right? Let me try to tell you, please be prepared with these names. Okay, so now let me go for some of the relations. I promise you, I'll never ask you to remember this many formula. People might say, giving a big list of 36, 34, 30, 40 formulas, and say this, why you remember this? Otherwise you'll not be able to do trigonometry. It's such a mess, right? But I say you remember only 6 basic definitions, and in between small memory aids by me, right? Let's see. Okay, before I find a relation, I'll go back to your previous knowledge, right? Don't get scared. I'm not going to ask you big questions, right? A very small question. If I think you all know what is reciprocal. I used reciprocal means upside down, making upside down. If there is a fraction, numerator divided by denominator, make it change. Denominator should come up, numerator should go down, then whatever you'll get is the reciprocal, right? So 0 is a number whose reciprocal is not defined. Otherwise we can get the reciprocal of all other numbers, right? Okay, fine. 0 is not a question here presently. We'll sort it out, right? If I give you a number, non-zero number, so x, what or how better you will define the reciprocal of this? How better you will define the reciprocal of this? Simple, 1 by x, right? Because if nothing is there below, means there's a 1. We all know that, right? So the reciprocal will be 1 by x. Now I am asking you a question. This is the question I am talking about. If I multiply these two, what do you expect to get? What do you expect to get? You might be thinking that sir is making fun with us, right? Is this a question? Yeah, that's one. That's one, right? If you multiply a number with its reciprocal, result will be 1. It's nothing other than that. Fine? Okay. Again, tell the words separately, because some people might be asking me a question. You are telling that reciprocal will be multiplied to any number gives you 1. Are what about the reciprocal of 0? I take back my words. 0 ko chhod ke, leaving 0, right? Any numbers, any non-zero numbers, reciprocal, if you multiply with that, giving you always 1, right? My tool. This is my tool. This is my tool for the next set of relations what I'm going to get. And I'm very sure you should not take extra pain to remember this. This is already in your 6-inch diameter ball, right? Okay. Now, let's see how do we use it. Definition should be called sin p by h. P by h. What will you get? Cosec sin p by h. But it reversed, h by p. Cosec. What did you understand? Sine and cosec are reciprocal of each other. What will be their product? What will be their product? You got a formula, right? First relation you got without any kind of effort. What you know earlier, use it with the definitions. Fine? Do not remember this. Remember only the fact that a non-zero number is reciprocal. If I multiply with it, gives you 1. Great. So, what will I get is sin theta into cosec theta equals 1. Now furthermore, just you tell, can you not derive from here sin theta equals 1 by cosec theta? Can you not derive cosec theta is equal to 1 by sin theta? That's it. I've written 3 things, 3 formula. Did you spend little of your memory which is going to put you in problem? No, not at all. You need not spend anything now. Whatever you already used, just reuse it. Nothing to be given input separately. Am I clear to you? Right? So I give you 3 formula from the first relation. And I promise you, you need not learn this. Because you are not going to forget this again. What will be the second pair? Cos. What is the reverse? Sec. Can you generate the next set of formula yourself? Right? You can do it. I'll be leaving only one for you. The second one I'm going to write. The second one is for cos. What is that? Cos theta multiplied by sec theta gives you 1. Then sec theta will be equal to 1 by cos theta. And cos theta will be equal to 1 by sec theta. Great. So you have learned 6 formulas so far without learning it. And then you have now one more pair of ratios, tan and the reciprocal of it, cot. Should I write this? You write it? I leave that for you. Right? So I'm sure that you can write this next 3 formula also. So you can count here 3, here 3, and then 3 more. So total 9 formula. Right? You are going to remember 9 formula without remembering that, without learning that, without any effort, remember. Right? Okay. Now, of course, I'm going to talk about 2 different relations now, which you have to put in little effort. You need to learn it 2-3 times you write. Once you write those formula, right, automatically it will be coming to your mind. So before I write this, I'll definitely show you how does this come, right? Actually, these are not difficult. Do not consider that I'm talking something very difficult, right? Supposing that I ask you to divide sin theta by cos theta. What sin theta is standing for? Ratio of P and H. and this is B and H. If you are going to simplify this will be P by H, and you know that the denominator gets reversed when you are talking about simplifications, right? So it will be H by B. This H will get cancelled, so this is P by B. What you will end up with? You'll end up with tan theta. So ultimately, where do we land? Our formula is tan theta equal to sin theta by cos theta. Tan theta equal to sin theta by cos theta. So I show you the working. In case of emergency, if you forget, then you can do this small work somewhere in the rough, and then you can bring this. But I'm sure that you will not forget that. This confidence I have, right? So you got this tan theta equal to sin theta by cos theta. Great. Now what was the reciprocal of tan? Cot. So for cot you need not do anything. Once you remember, cot theta automatically will come, because cot theta will be simply the interchanges, right? So cos theta divided by sin theta. So apart from those 9, right, those 9 formulae, these two you have to remember. So total how many you got? 9 plus 2, 11. Out of that, precisely if you remember, I'm talking about only those 6 ratios at the beginning to remember, and the small memory 8. X into 1 by x gives you 1. Great. So now this is all about our introduction to trigonometric ratios. Now we'll have to go for a little more. But today itself I'll not go for those formula. Rather, I'm going to take 2-3 easy problems so that you can at least start your trigonometry exercises, right? Great. So let me start with some very easy and the basic problems. But remember, trigonometry is such a chapter where problems can be so decorated that looking at the problem you might get scared. Is this a big problem? Right? It will come big as this to you. But actually the problem is this much. Okay? So question number 1, not difficult at all, just to recapitulate what we understood, right? That's the aim of these problems, nothing else apart from that. If I write 4 sin theta equal to 3, for some triangle, I don't know what the triangle is, no need to know it, right? If no angle is specified, this find cos theta, sec theta and tan theta. Look here, I am not talking about all the ratios. This question can be given like this also. If 4 sin theta equal to 3, find the remaining ratios. Yes, if you can find one of them, the other can be also easily found, right? Now how we'll proceed? See, we have many ways. As the triangle is not specified, I'm not going to make a hassle. I'll not consider any PQR or ABC, right? I'll simply draw a triangle where I'll fix the name as P, H and B. Nothing else, absolutely. Whenever it will be mentioned as, say, sine of angle A, then definitely I'll try to construct a triangle with A as one of the acute angle, right? But here not needed. Just you draw any triangle. Consider this as theta. Great. This is 90 degree. This is hypotenuse. Everybody can identify that. Then once this is theta, everybody can identify that this is P and this is B. This is very important part. Once you identify this correctly, rest of the problem will be easily solved. Great. Now, what we'll be getting from here? 4 sin theta equal to 3 giving me sin theta equals 3 by 4. Anyway, in between, let me try to tell you, I should have talked about the range, right, of the values of sin theta, cos theta, tan theta, etc. I skipped by chance. So anyway, in the next video we'll be discussing those at the beginning, right? Otherwise this will be a loophole, in fact, will be left out, and in higher classes you might be facing problems, or somebody might ask, kya trigonometric se kya aaya? Okay, so if you get sin theta equal to 3 by 4, what will be written in place of sin theta? Remember that your definition says sin theta is p by h. P by h. Great. If p by h it is, now do you say p is equal to 3, right, and b equal to 4? No, do not do that mistake, because you are not talking about the direct values. You are not equating the values, you are equating the fractions. Rather, I say ratios. Ratios doesn't say that these corresponding values are equal. They may be multiple of a fixed quantity. So whenever you get, this is a common mistake many persons, many students do. Please do not do it. Okay, for multiple choice questions, if you do some rough work, absolutely no problem. But if you are doing this in a problem which is description is needed, in which description is needed, then this will be a big problem, right? People like me might cut a mark, right? Okay, so here we'll be getting, see, I do not want to show you the complete process, you can easily understand. So if this is 3 by 4, it could be, actual value could be 6 by 8, right? 6 by 8, because ratio will be 3 by 4, maybe 9 by 12, right? So it means p will be the multiple of 3. At the same time, h will be also some multiple of 4, but at the same time, remember it, this multiplier k should be same for both, right? So k is a multiplier, that means k is a constant, right? So from here presently we have determined what is p, that is 3k, and what is h, that is 4k. Great, that's the idea we have to. Now you apply Pythagoras theorem, and then you try to find what is the third side. I'll do it here at the top. I'm preserving these ratios which I have to find, but otherwise I'll forget it. So what exactly I have to find by Pythagoras theorem? By Pythagoras theorem, what you will get by Pythagoras theorem? You'll be getting h squared is equal to p squared plus b squared, right? Put the value, it's 4 squares, that is 16, and then k square will come, then p is 3k, so it is 9k square, then this is b square. What will this b be giving you? It's 7k square. Taking square roots, you'll be getting this as root over 7k. Yeah, at this present moment we haven't taken the minus sign for the square root. Why? Do you know that? Yeah, exactly, we are talking about the measurement of sides, and if somebody says the side is negative, I don't know, right? So we have considered positive square root. Okay, so once you decide all the 3 sides, now whatever ratios you need, you can find it, right? So you have finished with all the ratios, all the sides, and now let me just go for finding the ratios. What is the ratio? First ratio they are asking is cos theta, right? Cos theta, just quickly remember what is the ratio of cos. Cos is the ratio of what? B and h, right? B by h. What is b? B is root over 7k. What is h? It is 4k. K got cut. Your answer is root over 7 by 4. What is sec? Oh my god. Sec is just the reverse of cos. You need not even find the ratio, right? So you directly write this as 4 by root over 7. And then the last one is tan theta. Tan theta will be the ratio of p by h, right? What is p? 3k. Sorry, p by h, galat. P by b. P by b. B is root over 7k. Getting cut. 3 by root 7. Great. Right, so today I'll not go further. We'll fix it here today. and then we'll come back with another video. So till then, I do have you'll be finishing with the basic trigonometric ratios, and you'll remember all those 9 relations with the 2 extra ones, and keep the memory aid alive forever, right? Till then, bye bye. We'll be coming back soon with the next video. Bye.